how many non-zero integer values of x satisfy the equation given below such that x is less than or equal to 10. If you are looking at the inequality that is given, the numerator is x cube minus 8x square plus 17x minus 10, and the denominator is x square plus 6x plus 5 into x square plus 1. This has to be greater than 0. One of the first things that you should realize is that x square plus 1 is always positive. X square is a perfect square, so it is always greater than or equal to 0. So x square plus 1 is always greater than or equal to 1. So when you are trying to find out the values of x for which the given inequality is satisfied, you are essentially looking for the values of x for which x cube minus 8x square plus 17x minus 10 divided by x square plus 6x plus 5 is greater than 0. Now for the function to be defined, the denominator should not be equal to 1, and the denominator can be factorized to equal x plus 1 into x plus 5. And if you don't want this to be equal to 0, x cannot equal minus 1 or x cannot equal minus 5. That is, x cannot be minus 1 and x cannot be minus 5. What is the numerator? If you are trying to factorize the numerator, it is x cube minus 8x square plus 17x minus 10. If you substitute the value of x to be equal to 1, the numerator becomes equal to 1 minus 8 plus 17 minus 10, which is equal to 0. This would imply that x minus 1 is a factor of the numerator. If you are trying to factorize it such that you want to take x minus 1 common, this will be equal to x cube minus x square minus 7x square plus 7x plus 10x minus 10. This is the numerator. If you are taking x minus 1 common from all the terms, you are going to get the first term as x square into x minus 1 minus 7x into x minus 1 plus 10 into x minus 1. Or the numerator is equal to x square minus 7x plus 10 into x minus 1. This can be factorized to equal x minus 2 into x minus 5. So the given inequality is x minus 2 into x minus 5 into x plus 1 divided by x plus 1 into x plus 5. And we want this to be greater than 0. When you are looking at an inequality, the first thing to again do is remove the denominator. So multiply the left hand side and right hand side with x plus 1 whole square into x plus 5 whole square. That is the square of the denominator. The square will always be positive, so the sign of the inequality will not change. So the inequality we are essentially looking for is x minus 2 into x minus 5 into x plus 1 into, this is x minus 1 at the top. We made a small mistake. This also is x minus 1 because we took x minus 1 common, not x plus 1. So this becomes x plus 1 into x minus 1 into x plus 5. We want this to be greater than 0. What are the inflection points for this product? The inflection points are 2, 5, minus 1, 1 and minus 5. So now if you are looking at the number series, and if you have, if you are pointing down all the inflection points, the smallest is minus 5, the next one is minus 1, next is 1, next is 2, then is 5. If x is greater than 5, all the terms, all these 5 terms will be positive. So their overall product will be positive. If x lies between 2 and 5, one of them will be negative and all the others will be positive. The term which will be negative is x minus 5, but all the remaining terms will be positive. So the overall product will be negative. Similarly, between 1 and 2 it will be positive. Between minus 1 and 1 it will be negative. Between minus 5 and minus 1 it will be positive. And less than minus 5 it will be negative. Because when you write the inflection points, you can check them manually, but it is always alternating. Because one additional term will keep on getting negative as you keep moving through the inflection point boundaries. So if you are trying to find out the integers which are less than or equal to 10, for which the given inequality is positive, it has to be greater than 5. So they will be 6, 7, 8, 9 and 10. That is this region. This region it is negative, so we can ignore it. Between 1 and 2 it is positive, but there is no integer which lies between 1 and 2. So even though all the numbers which lie between 1 and 2, the inequality will be positive, there are no integers in that given space. Between minus 1 and 1 it is again negative, so we can ignore it. Between minus 5 and minus 1 we again have some integers. They are minus 4, minus 3 and minus 2. Less than minus 5 negative, so again we can ignore it. So the total number of integers which are non-zero which satisfy the given inequality such that x is less than or equal to 10 is 5 plus 3, which is equal to 8.